Okay. So, I'm going to build it up a little bit. When I was a little kid, I was really bad. I still am. I have to do this when I'm given directions about left and right. Anybody know why? Yeah. The one that makes an L is left. So I got too much other shit in my head, right? Math dude, I got all this other crap. Left and right just escaped me from when I was a little kid. I hated the fact that when I was taught sign notation, it was taught move it left, move it right, and that's really actually a pretty stupid way to teach it. Because it's a much more direct way to teach it. Now, if you like left and right, you've been taught that way, cool. Keep doing it. Here's the way I kind of know how to do this. I'm not going to do this directly, so for those of you who remember it, just hold off. Just kind of go with me for a minute. I can rewrite this as 4 times 1,000, right? And really, the whole motivation for this is if I have a bunch of zeros, I don't want to write all those freaking zeros. Right? I just want a quick way to tell somebody, oh, it's followed by this many zeros, or it's kind of this big, right? I don't want to have to write all the zeros out forever. So a better way to write 1,000 is 10 to the what power?
3.
I love it, because 10 times 10 is 100, times one more 10 is 1,000. So 1,000 is 10 cubed. So that is what scientific notation really is. It's not really just a symbol, it's an actual little equation that works out to be 4,000. That's the one place that we still have the X for times, a remnant. We just leave it there. Cool? So what about the other way? What about if I had 0.004? Let's just do, yeah, that's fine. 0.004. Can somebody help me out? How do you write that as a fraction? What place is that in? Tenths, hundredths, thousands. What did we just say we could write 1,000 as?
10 to negative.
Well, careful, 10 cubed, right? 1,000 is 10 cubed. Is that cool? Now, if I do bring this up to make it look like this, what must change? The exponent. Because if I move it, it really wants to be down there, right? So I'm like forcing him up there against his will. So when he gets up there, he's going to be pissed. So it's 4 times a negative 10 there. A 10 to the negative 3. So now look, doesn't a negative power really kind of mean division? Because if it's times something to a negative power, doesn't that flip down? So doesn't it make sense? Instead of left and right, a negative power is a small number. A positive power is a big number. Then I don't have to worry about freaking left and right. Right?
Wait, explain that again?
If it's to a negative power, it's going to be a small number. So you got to move the decimal that way, whatever that way is. I got to make the number small.
Okay.
Because it's being divided by that many tens. Wasn't it going to be really small? Whereas if it's a positive power, it's being multiplied by that many tens, so it's going to get big. So I'm going to move the decimal that way to make it big. So, for example, going the other way. If I had 7 times 10 to the 5th power, is it going to be a big or a small number? Big, because I'm multiplying by 5 tens. I'm not going to flip it and divide it. So I want to move the decimal that way to make it big. How many times?
5.
So right now, where's the decimal? There. So if I move it that way 5 times, 1, 2, 3, 4, 5, there you go.
Can you give another example for the one of the negative?
No. Yeah. I will. What about, sorry, 3 times 10 to the negative 6? Now again, if you know your left and right and all that kind of stuff, that's, you know, I'm jealous, and you were taught that way and you remember, that's great. But to me, it just made a lot more sense. It just made a lot more sense that a negative power means small, so I'm going to make it small. Yeah, and don't even worry about how to name it, just how many zeros are going to be in front of it. There's a kind of nice shortcut. I always have to move it once, right? And then how many more times do I have to move it?
5.
So there will always be one less zero than this in front of it. So just got to go 1, 2, 3, 4, 5, and then a 3. So that's been moved back 6 times. Is that cool? Oh, sure. Whatever works. All right. So I've been using whole numbers on purpose, but this works for any kind of number in front of it. So here, try this one here. What would, how do you write this here? think about it the same way we thought about this one. How many times do you have to move it just to get around all the numbers? And then how many more zeros would there be then? Yeah, you got to move it 3 times just to get it past these numbers, right? And I still have to move it 5 more times, so 5 zeros. It makes it a lot quicker than trying. I remember when I was looking, trying to do, and then you got to remember there's a 0 that goes in. Oh, screw that. 3 times to get around there, and then 5 more times to complete the 8, right? 1, 2, 3, 4, 5. How we doing? Now, we need to talk about going the other way.
No.
Yes.
I like the
Aw. So this would be if I have something like this here. Then the mistake people always make is they stop the decimal in the wrong place. What is always true? Every time it's in scientific notation, how many digits are in front of the decimal place? 1 digit, right? It's because scientific notation, I always think of it as like a tens vampire. It wants to suck all the tens out of something. So if this would have been here, that's 11, that's got a 10 in it. The decimal's in the wrong place. It should have a number between 1 and 9 in front of it, so there's no tens in it. So where do I want to stop the decimal? Right there, right? So how many times do I have to move it to get it there? 1, 2, 3, 4. So 1.09 times 10 to the 4, but it's a small number, so it's negative.
Wait, why'd you something?
Because the decimal always has to be after a single digit. If I would have went 1 further, isn't there a 10 there? I should have no 10. I want to collect all the 10s here. So it should have a single number in between 1 and 9, so there's no 10 in it anymore. If I would have stopped the decimal here, that would have been 1/10. There's still a 10 on the bottom. I didn't suck that one out. Weird for this, right? You guys, so you just always move the decimal until you have 1 digit left in front of it.
Got it.
Let's try one more here. You'll notice something really nice about large numbers. They're already grouped by
0.
3s, aren't they?
3.
So that's pretty damn quick.
I didn't say anything.
I don't remember you saying anything.
I don't know either.
So how many times do I have to move the decimal to get it back? Where do I want the decimal to stop?
6 point.
After the 6, right? 6 point something? How many times do I have to move it then?
2.
If I move it twice,
Oh, you gotta start way over there.
where's the decimal currently?
At the very end.
At the end, because this is a whole number, right? It's a big ass whole number. Yeah, so if it's back there, you got to move it 3, 6, 9, 12. See, that's the nice thing about really big numbers. The commas will make it a lot quicker to count, right? So how do I write that then? 6 point 10 to the 12th.
So you couldn't write all those zeros?
It's never going to be point something, it's just going to be a number.
A number point something, yeah.
Easy.
What's up, Jeff?
You just can't write all those zeros.
I don't want to write all this. In fact, that's the whole point of this, is I want to condense it so I don't have to write all these zeros. All those zeros, what do? They're just like placeholders, right? Like 7 means 7. I put a 0 there, now that's still a 7, but now it means 7 tens, right? Put another 0, now it means 7 hundreds. Are those zeros really important? No, there's got to be another way to tell somebody how big the number is without having to write all these freaking zeros. If I want to write 7 with a bunch of freaking zeros, screw them. Let me just write 7 times 10 to the 30th. So I don't have to write 30 freaking zeros after the damn thing, right? That's the whole point of scientific notation, is to make it quicker to write a big-ass or small-ass number. So if you guys go on to chemistry or astronomy or any of these me's, then what's going to happen is you're going to see these really small things in chemistry, the distance between atoms. You're going to see these really big things in astronomy, the distance between stars, and you're going to be using scientific notation a lot. Instead of writing, 80 billion kilometers between this star and that star, let me write it as 8 times 10 to the whatever, right? Yes?
How did you know to put the dot after the 6?
Because that's the whole idea of the notation. If I stopped here, 60 has a 10 in it. It's 6 times 10. So I didn't suck a 10 out of it. If I stop there, that's 6/10. It has a 10 on the bottom. I don't want any. I want a nice number in between 1 and 9, less than 10, bigger than 1/10.
So it has to be between 1 and 9.
Exactly.
I still don't get
A single digit in front of the decimals.
I still don't get why we don't write the zeros. I know you just explained.
Do you guys?
Because that's the reason
Is
why
that
it's 12
what's? Is that the same as this?
It's like writing x plus
Is the same as that?
Okay.
Right? Aren't these all the same? Isn't this the same as that? The same as this?
Yeah.
Now in science, these are different because in science it means how precise you measured something. So these people went crazy. They measured it way out to here. Mathematically, math looks at it and says, what the hell's your problem? That's all 7.
We're not scientists.
We're in math right now.
Exactly.
Exactly.
It's just like 83,200.
What?
Yeah, what?
It's like 83,000.
Okay.
You see his face like, what? This face is like,
83,000? 350 like that?
That's 83 right there.
No. How many digits do you want from the decimal?
1.
1. So where are you going to stop? Right? A single digit in front of the decimal. And I had to move it 3, 4 times, right? Okay.
And it doesn't get harder than this?
No.
Are you sure? You're lying to me?
Watch this. Here's the hardest you'll see, at least with me.
Yeah. Da Vinci's code still in there. National treasure, man.
No, you don't need any special glasses
Alright.
to look at this. No.
Okay.
I've seen that. It's like back when Nicolas Cage made videos.
Exactly.
What's your gut feeling on this? Let me just kind of let you guys look at that and see what you think. How?
Because there's a negative.
Do you see how this is really almost the same idea as this? What would this be? 4x times 2x. What's that? 8x squared. You did the numbers and you did the letters. Let's do the numbers. 4 times 2 is 8 times 10 to the what?
5.
Okay, bam.
Wait, hold on. Time out. Let's do this again.
Are you guys cool? Because what's the only operation in this whole thing? What's operation in this whole thing?
I'm telling you.
Multiplication, right?
Yeah.
And I can multiply whatever order makes sense to me, and 4 times 2 makes sense. And this many tens, that many tens, I can use exponents to do that, right? Bam.
This is not good. It gets harder than that.
A little bit. I don't think I took us too much beyond that. Somebody have their homework sheet right there? What's the highest number I gave you?
Oh, you did make it a little easier, I'm not gonna lie. Especially
The highest
for,
number you go to is 75.
5.1.
63 through 75 every third.
Oh,
I mean,
and that's
no.
like review.
No, I'm sorry. 15 through 42 every third.
42, okay.
Yeah. 15 through 42 every third.
So nothing major.
Are we done for the day?
No. All right. Hey guys, do this one. Change this into scientific notation.
It's already done.
Change it into scientific notation. No, I don't blame you though. It's always a good thing to try. Because if it's true, then hey.
Always is a negative.
So we moved that
I don't know.
4, 5, 6 over 6 times.
All right.
8.9.
1, 2, 3, 4, 5, right?
Okay.
Oh, here?
Yes.
You went.
Do we still keep it a negative?
Yeah, watch. What's that? How do I write that in scientific notation? What did you just figure out? 8.9 times 10 to the negative 5. And you put a negative on it. Right? It's a negative number here. It better still be a negative number here. So don't let that negative in front bother you. It's just like a positive in front, right?
Even though it's 0.
So again, it's not a 0. It's negative 0.0089. Negative 0 wouldn't really make much sense, right? It's a negative small number, but it's still a negative number.
How can we put the 10 in? What is the 10 for?
So, help me out here. 0.1. What is that as a fraction?
1.
1 over 10.
1 over 10. Which can be written as 10 to the negative 1, right? 1 times 10 to the negative first. How's that? Right. If that 10 comes up, isn't it to a negative power now? Because it really wants to be down? So that 10 comes from the decimals. What number is our system based on? 10, right? So decimals are just fractions with 10s in them is really all it is. Why do we have a special way to write them? Because they're decimals with 10s, and our number system is based on 10. That's why decimals can be written in a special way,
You mean
because they match up with our number system.
What do you mean the number system is based on?
Our number system, do you guys understand our number system is based on 10? Because what does this mean? 7 hundredths, which is 10 squared. 2 tens. 1 1, which is 10 to the 0 power. Really? Do you guys see what I'm saying? Our number system is based on 10. If you take Math 120 with me, I teach you about number systems, how they would look if they were based on like 8, or based on 12, or based on
So
60.
Math 120 is not really math. It's just taking free
No, Math
stuff.
120 is math. One piece of 120 is talking about like the Babylonian number system, the Egyptian number system. And the reason that that's important, is because you guys need to understand that the way math is not the way math had to be. There are other ways to do everything we do. It's just the way that was agreed on way back when, and we still do it the same way. There were a couple of people who created their own kind of math ways, and it's been accepted, and we do some stuff in there that's easier to do with that. But I can totally understand from your perspective. You have no idea what the hell it might look like different. But that's what's beautiful about Math 120. It just gives you a little bit of insight of what could have been different. Like in Egyptian, the number for a million is a fat little excited dude. That's the number million. Excited person.
Are you serious?
You've seen that before.
That's
There you
1
go.
million.
That's 1 million.
That's
10 is a heel bone. Stuff like that. Babylonian,
So we learned that.
Okay, so all my next tests are going to be writing that stuff.
it better be right. If it's the right number and you make it Egyptian correctly, I'm happy.
I'm just going to draw you a picture.
I like it. The picture better be the right answer.
So,
Anyway, I don't want to get too much into that. That's if you take 120, you can talk about that.
Every time the decimal moves to the right, it's negative, and it's a positive left.
yes.
So that's that, and I'm not going to teach that.
I'm just asking.
But that's true.
Is it true?
If I move it to the right, it'll be negative. But what I hated about that is, if it's in this form, which way do I move the decimal to make it back into a regular number? I move it to the left. It's like, it totally depends which way I'm going. Whereas, if you know that a negative power means small number, well, a small number has a negative power, and a negative power makes it a small number. I don't have to remember which way means which.
How come you said you're not going to teach us that?
The left-right way. Because I personally think it's confusing. I don't care if you even know left and right. So real quick, last thing on the scientific notation.
I need to figure out
Which way do I move the decimal here to make it into scientific notation?
To the left.
To the left. 3 6 times, right? Now, which way do I move the decimal now to put it back into a regular number? To the right. Shit. Do you start to see my... So if you add on top of that a kid who's not really good with the left and right, that kid's going to get confused. Whereas if you just tell me a big number is a positive exponent...
Sorry, I didn't know what you meant by the left, right?
No, I'm with you. No, okay, I got you. A positive exponent means a big number. I don't care about left and right now. I just make it big. Which I move it in the direction that makes it big, whatever direction that is. Right? No, that's cool. Okay. All right, guys. Woo, man. No, I totally love questions about stuff that troubles you. I just am worried sometimes that you're making it seem more complicated than it really is sometimes. But you ask good questions, but I don't want you to get too worried about too much other weird stuff. So I definitely want to do 5-5 before I let you out of here. You guys have gotten way too spoiled.
That means that there's going to be homework by tomorrow. Tomorrow.
All right, cool. Let me see what you guys already know. First thing is definitely nice. What's really cool is if you see a section that talks about polynomials, who can tell me what you're not going to see that would normally make it a hard problem? What's true about, negative powers. You know you're not going to see any negative powers. So this is all about multiplying polynomials. So for example, I can multiply a monomial times a monomial, right?
Yes.
And that's pretty damn simple. Hopefully we all agree with that statement. There's not much to that problem, right? So what would that become now? That's what I was looking for.
You distribute, right? Or no?
No distribution required, because there's only one term inside, right? You distribute to several terms, but there's only one term. So 4 times 7?
28.
28. X, M, cubed. I love it. Because there's only one x and there's no more x's, so it's still just one x, right? You just multiply as you go. 4 times 7 is 28. M times m squared is m cubed, and there's an x in there.
So why don't we distribute? Because there's
Distributive property is a way to get around having to do inside the parentheses first. So if I have 4 times 2m, I don't have to distribute because it's only multiplication, right? I only have one 4. I can't have 8 times 4m. I got 2 4s in all of a sudden. So 4 times 2m is really 2m plus 2m plus 2m plus 2m, right? And that's, of course, 8m.
Wait, if I
Oh,
was
no.
looking at that problem, I would do 4m times 7, and then...
Well, don't do that. You do the parts that you can do.
So you only do 4 times 7?
Let me ask you guys this. How would you multiply?
Like terms, right?
How would you multiply that?
I
I personally kind of look for my tens. 2 times 5 is 10, times 6 is 60. So don't you multiply by whatever is easiest to do?
Sure.
Well, here, easiest is actually you multiply by whatever is possible to do. Can I multiply m times 7? Not really. I can't put those together. But 4 times 7 is 28.
But you can multiply it.
Not really. I can multiply 3 times 4 and make 12. But 7 times m can't go together. It's just 7m. I can't put those together. But 7 times 4 is 28. M times m squared is m cubed.
Is this where all like the only combining like terms would come in? Big
Okay, I
time,
get
or
it
no?
now.
It's not like terms because what operation are we doing? Multiplication.
Oh, so you don't need like.
So like base is really when you multiply for the exponent power, for the exponent property.
And it's not the answer.
Sure.
But that's the answer.
Yep.
You can charge it.
Thanks. Oh, is it R? Oh yeah, okay. All right, what do you think about that one there?
It'll be, what is that?
Same idea.
Negative 18.
9 times negative 2 is?
Negative 18.
And negative 18. R cubed.
R cubed.
Any R's? No, so just R cubed.
And then
S squared. Because R can't go with anybody, so it's just still 3 R's there. And S can't go with anybody, still just 2 S's.
Is this S cubed, S squared?
If it would have been S here, then you could have put those together, of course. And you would have had 5 S's, S to the 5th. Beautiful.
And you only do this
But if the bases are not the same, you can't put them together. You can't accumulate them, right?
You only do this in multiplying by
Well, you only do this when multiplying. Yeah.
You say we won't see any negative exponents when multiplying polynomials?
Exactly. Because the definition of a polynomial excludes the possibility of negative powers, remember? Polynomials can only have whole number exponents. Whole numbers are not negative, which is kind of nice. It's actually easier than in the earlier section with negative powers. We don't have anything to worry about flipping. What about this here? So going to the next level here. Oops. Now, exactly. Now there's a plus sign in there. So what property comes into play? Distributive property. So if you really need to, let me show you something you can do. You don't have to do this next step if you don't need to. But one thing you can do if you have any trouble with this is you can write 4a squared b times negative 2ab squared, right? This times this, plus 4a squared b times 3b. Do you guys see that? You distribute that to there, bam, that to there, bam. And then on your next step, you can worry about what the hell this is. Now, some of you guys could probably do that times that kind of in your head and put the answer down. But if you have any trouble with that, you can kind of show yourself what's going on. So what happens here? What do I get there?
Negative 8.
Good. Negative 8.
A cubed, B cubed.
Yeah, A3, B3. I like it.
Plus 12.
12.
A squared, B squared.
A squared, B squared. I love it. Now, can I go further? Do I have any like terms?
No.
Do I have anything else that has 3 A's and 3 B's? Do I have anything else that has 2 A's and 2 B's?
Nope.
So be careful. I always see somebody do this, and then they go and they say, okay, that's 4A5, B5, or something neat.
So it's not the only.
Do you see any A5, B5s in here?
No.
So how can somebody claim that there's 4 of them when I don't see any of them, right? What's it mean to be like terms? The same variables and the same amount of each variable. Those are not like terms, right?
Right.
Okay, cool. So when I add if I had 3 horses and 2 pigs, that does not make 5 horse pigs, right? I mean, it's really, that's what it is. It's physical. I can't accumulate these. But if I had 3 horses and 3 more horses, that's 6 horses. I can put those together because they're like terms. They're like things. I can accumulate horses. I can't accumulate man-bear pigs or horse pigs. There's a few could do that. All right. What about, here, you guys try this one. No? Okay. So what do I get here?
Negative.
Negative 10.
Okay, so when I do this,
M cubed.
good. Negative 10.
M cubed.
Good. M times M squared is M cubed.
W
4W is one more W, W5. Good.
plus
Plus 6 M 4, right? 1 plus 3 more is 4 M's. W to the 6. All right. See, I mean, that's what that is. I mean, don't go further. The powers don't match up, so they're not like terms. Right? Oh, that's the next to that buck. So see how I'm kind of building. I did monomial times monomial. What did we just do? A couple of. Monomial times binomial. Now we're going to do binomial times binomial. See what the hell that is. Yeah. The nifty thing about that, I want you to think about this. If these were like terms at the end, these would have had to have been like terms. There's no other way around it. So I would have put them together at this step. If these are not like terms, and I multiply them both by the same thing, can they be like terms at the end? No. They're still not going to match up because they're both getting the same amount of stuff. They can't match up. You guys see what I'm saying?
People are just used to simplifying it.
I know, but you got to fight the urge to simplify that which you cannot, right? You cannot simplify that anymore. No like terms. Cool. So somebody suggested that I do this, which is a perfect segue into doing it, because the next level then is a binomial times a binomial. Which, to tell you honestly, I have nothing against FOIL method. It just doesn't work when I go to the next step up. I want to show you what FOIL method really is. You don't even need it. Now, if you like it, I'm not trying to take it away from you. Keep doing it. FOIL it out, whatever. I'm going to say that word also a lot. But here's what is really going on here. Okay. So really what's going on is I'm going to multiply this by both of these and this by both of these. So FOIL method is kind of a way to remember things so you don't leave anybody out. But here's why you don't need it. Here I only had one thing in front, right?
Yeah.
So I just had to take that thing to this and that thing to this. Here I've got two things, so I just have to distribute twice. I don't need FOIL, I really don't. If you like it again, keep it, I love it. But all I gotta do is distribute this to both. So what do you get there?
X4.
I like it. Plus 7x squared. So I distributed that to both. Now distribute this to both. Do I need anything to tell me what to do? No, I don't need. I just distribute each piece one at a time. So what do you get here?
Negative 3x.
And you get 21.
Good, minus 21. Now what we just did was we multiplied the first things, F, the outer things, O, the inner things, L, the last things, L. Do I really need that? No. I sort of wish they wouldn't teach it. But if you like it, I understand. But you don't need it. There's no purpose for it. Distribute that to both. What's that? Beautiful. Is it better if I don't call it FOIL? Distribute that to both. That's what we did here. Distribute the negative 3 to both. That's what we did there. Now what can you do there?
You can do
Combine like terms.
X4 plus 4x.
There are actually like terms up here, right? Where are my like terms?
7x squared is greater than 3x.
Beautiful. There's no more x4, so I can't do anything with that guy. But 7 of these minus 3 of these is 4 of these. Factoring is the next chapter, which would be starting here and going that way. That's what factoring is. Factoring is the opposite of simplify. Right? Simplify would be 2 times 5 is 10. Factor would be 10 is 2 times 5. They're opposites, right? That's the next chapter.
There's 1 of 3 after this. Then is it 1 of 1?
Yes.
You want 3?
Here we go. You ready? Here's what you're saying.
Are we doing factoring?
Factoring is the next chapter.
Oh.
Yeah. Got to finish 5 before you can get to there. No, look at this. Watch this. I'm going to purposely do something interesting with this. Now see, this is where, the minute I make the problem longer, people think it's harder. It's just going to take a little bit more time. It's not harder at all. What do I do with this x?
Factoring first.
Multiply it through, right? So x times x squared.
X cubed.
X to the third power, love it. X times 3x.
3x squared.
X4.
3x squared, careful. 3x squared. X times another x is just 2 x's, right?
Oh shit.
Oh shit. X times 9.
9x.
9x.
Okay, so I did this, he's done. I still have to take this guy through, right?
Minus 3x squared. Minus 9x.
Yeah, 339x, good.
Minus 27.
Right, you guys see that? So you can imagine, I'm not going to make this terribly much bigger, but I could make both of these as big as I want. You just take each thing in here one at a time and distribute it through. That's all you do. So now what can I do here?
Who cancels out that?
Anybody go with him?
X
No.
squared minus 27.
Yeah, he's alone, right? Poor little dude. But who goes with this guy?
It cancels
And
out.
those cancel. Who goes with this guy? That guy, they cancel. And then maybe go with the minus 27? No. Some of you guys might remember difference of cubes. So I purposely made this so it would work out to this. So that's going to be, again, chapter 6. But right now, I just got to multiply it out. That should be relatively easy. Multiply like terms. Right? That's really what this section's about.
Factoring that back in could be kind of hard.
Factoring that back is that's the one that students normally hate the most because it's the one that you have to memorize the most. The other ones you can kind of work. Cubes, you have to memorize the form. And that's why most students hate it the most. So here. A couple more and then we'll leave out. We'll head out. I've spoiled you guys so much.
Oh, thank you, though.
Yeah, you better appreciate that. Since I didn't, oh, I'm sorry that I was feeling
I
bad.
fell asleep in my car, and I didn't plan on it, and I woke up 3 hours later, and it was exactly 2:45. And then I went to class, and it was canceled. And I went home.
I'm really sorry. I'll try not to do that. What about this here? Do that one. And then we'll do one more after that, and then we'll head out.
So you gotta distribute every single part, right?
Each piece, one at a time. So let's see. So the x, catch up to you guys. The x I've got to distribute through 2x squared,
Square. 3x.
3xy
Minus 7x.
minus 7x.
Minus 2xy.
Then I got to bring the y through. Good. So minus 2xy. Good. Minus 3y squared.
3y squared plus 7y
3y squared plus 7y.
Good. Plus 7y.
Plus
plus
8x.
8x
Now I got to bring the 4 through.
Plus 8x.
Plus 8x.
plus 12y
Plus 12y.
Minus 28.
minus 21.
28.
28. Yeah.
28.
Whew. Man, they jump all over you. You're silly. So then, now I look for what? Like terms. And let's see. Any more 2x? Any more x squares? No.
No?
Any more xy's?
Yeah.
Yeah.
The xy only.
Good. So 3 minus 2 is 1xy.
Plus
Any
x.
more x's?
Yes, there's 8x.
Good.
It's gonna be
So plus x. Any more y squares?
No.
No.
Minus 3y.
Any more 7y's?
Yes. It's gonna be.
I mean y, sorry. So,
9y.
and then finally, poor little 28's by himself. So you should expect, the minute I start adding terms into each piece, you should expect your answer to possibly get really big unless some stuff cancels, right?
Can you put this in order?
Oh, shit.
It's not put in order from the minus x.
You could, but it's not necessary. In fact, here I'd have to tell you according to which letter. If I said by x, then it should be the highest value of x to the lowest. But I could say by y. So if you don't put in some kind of order at the end and I don't ask you to, then don't worry about it. Right. Normally you put the highest degree term first, but when there's a lot of variables, you got to say, okay, you want the highest x term or the highest y term or which one? So don't worry about trying to put these in order unless they say put in ascending or descending order. All right, the last one I want to do, like I said, there was 2 more here. This is the last one.
Wait, that's the answer?
That's the answer. 'Cause there's no more like terms, right? Are there any more like terms? Any more x squares? Any more x y's?
2x squared, 2 plus 3y squared, 2 15x plus 19y.
I'm not sure where the 15 came
There's
from.
no-
Oh, negative 7x plus 8x is plus x. Yeah. Okay. So what about this here?
You can't just add the
Well, you got to put them together. Negative 7 plus 8.
No, I meant the x
What?
and the xy.
Are they like terms? Do they both have the same variables and the same amount of each variable? No. So try that one. Careful. Not quite right.
I was like, man, that's a good problem, man.
Minus 16x.
Almost.
Just 16x
Negative
squared.
16x?
Almost.
Negative 16x squared.
Yes. So let's see. Let's just do it one at a time. So 7 times 7 plus 28x minus 28x.
Minus 15x squared.
So of course these go away. They cancel each other, right? 49 minus 16x squared. Some of you guys might realize that's a difference of squares. Again, that's going to be a chapter 6 thing.
Thing is negative 16x squared plus 29.
Exactly. It's the same thing. All right. I think that's plenty. All right, guys.
Oh, Mr. Wade.
Take.
What's up? 4 point, 4